Exponential functions and equations. The first one looks like it's going to be super tricky, but once you know the secret, hopefully it's not too bad. They give us a table and they tell you it represents an exponential function and it wants you to write down the equation. And that can seem really overwhelming unless you know the steps. So the first step is pay attention to the x equals 0 spot. Now we can't come up with an exponential function unless we remember that we've got this going on. Anything raised to the 0 power is what? 1. Yep, anything raised to the 0 power is 1. So what this is telling me right here is when x is 0, my function equals 36. So think about that. What variable would have to equal 36 if when x is 0, I get 36 for y? Anything raised to the x is what? Or anything raised to the 0 is what? 1. 1 times what number would be 36? Yeah, a would have to be 36. So a would equal the x value, the y value. So now I've got y equals 36, b raised to the x. And I've got to figure out my b value because our equation will have x and y. Do I have a whole list of x and y's over here? A whole list. So our next step is pick a point from the table you like. Some people hate negatives, some people hate big numbers. So just pick one of the numbers you like. I fair to bet somebody's going to like 1, 6 and somebody's going to like 2, 1. So let's just go by majority. Who wants 1, 6? 2, 1? You guys win. All right, so we're going to let x and y equal that. Substitute in for x and y. And then we're going to solve for b. So let's see. 6 equals 36. B raised to the 1. B raised to the first is just B. So now I've got 6 equals 36B. So B is 6 over 36 or 1/6. Last step, I guess, would be write your equation. So we'll have y equals, our A was 36. The B we just solved for is 1/6 raised to the x. Do not be tempted to multiply those together and simplify that, because remember order of operations says you'd have to do the exponent first. So that's something you cannot multiply. So what looked horrible hopefully wasn't too bad. Okay. I believe you covered these in Math 1. Let me know if otherwise. Exponential equations can't always be solved this way, but today they can. We're going to use common bases. So let me rewind before we start doing those problems. If I have 3 to the x equals 3 to the 5th, what does x equal? Five, right? If my 3's are equal, and we've got that equals thing, my exponents have to be equal. They have to be the same, right? That is what your equations are going to be based on today. We're going to find like bases, and then the exponents are equal to each other. We might have to do a little work and solve, but we can do it. So 125 and 25. If you can't see a common base, break it down like this. 125 can be rewritten as 5 to the third. 25 can be rewritten as 5 squared. But that 25 already had something going on up there. It had this. So you just times them. Now, my bases are the same. If the bases are equal, what do we know about the exponents? They're equal as well. So I can just rewrite this as 3 equals 2 times negative x plus 5. I'm going to have to write tiny. Negative 2x plus 10. Negative 7 equals negative 2x, so x is 7 halves. All right, let's do another one. 4 and 16. What base or bases could they have in common? Oh, wait. 2, or I also heard it over here, 4, either one. We can get the same answer using either one. I am going to rewrite this as 4 squared instead of going all the way down to 2. Five minus 3x. Your exponents would just have an extra factor of 2. If you broke it down to 2, we'll get the same answer either way. My bases match, so I can set the exponents equal to each other. Whoops, I lost that 2 right there. Got negative 4x equals 10 minus 6x. 2x equals 10, so x is 5. Do you remember doing this in Math 1 or Math 2? Or is this new? Newish? Okay. I'm glad we're spending time on it then. On this problem here, can I take it down to 4 like I did a second ago? 16 was 4 squared, but I can't write 8 as 4 raised to a power. So this one does have to go all the way down to 2. So I know 8 is 2 cubed. I have an x minus 2. And I know 16 is 2 to the what power? 4, yeah. Bases match, so that means my exponents are equal to each other. X is 10/3. All right, try that last one with a neighbor or on your own. I'll start writing things here in just a second. Give me this much. What base are you using? 2? Does anybody use 4? All right. They both work, right? They both work. We can say 64 is 4 to the 3rd. Or you can say 64 is what? 2 to the 6th? Is that right? Yep. Had to think about it. And then our 4 is 2 squared. We will get the same answer either way. Here's a 3 minus 9x equals 12x negative. 3 equals negative 3x, so x is negative 1. Let's see if I get the same thing. 6 minus 18x equals negative 24x. What is that? 6 equals negative 6x, so x is negative 1. Either way. So don't be worried if you're doing it differently than your neighbor.